Right. Good evening, boys and girls that are watching today's fifth lesson on STEM Digital School, Technical Sciences, Grade 12. My name is Spiro Sibanyoni, and I will be your teacher again for today. And we will be wrapping up the topic, and in wrapping up this topic, what I also want to do is I want to share with you some of the common mistakes that some of the learners make in this particular topic. And I have selected a question that will help me and help you as well to be able to address some of these common mistakes that happen, because these mistakes are going to penalize you, are going to cause you to be penalized at the end of the year during marking. And as a result, I want you to take care of all these things that we will be talking about. So I hope you are ready. You have your pens, you have your paper, and we are good to go. So I trust that you will definitely enjoy this particular lesson. Right. So let us go to it. Right. Right, so we are doing diagnostic errors in Newton's laws, and we will do that through at least a question that will help us to address all these particular gaps, right? Now, the overview of today's lesson will be the diagnostics, and we will be looking at integration of these laws, diagnostic errors and tips. And for our assignment, we'll be doing the November 2019 question. That is question number 3 from Technical Sciences Paper 1. And we will be integrating all of these laws in that particular question, as well as the diagnostic errors and the tips as to how to avoid that. And lastly, we will also learn generally how we can fix these particular errors that we have been making perhaps before, so that we are able to collect all the marks at the end of the year, right? I believe that is what everybody wants to achieve. Now, remember, yesterday we dealt with Newton's third law of motion, and we looked at various number of examples. And today, and we also did just a question on that, where we were actually looking at action-reaction pair of forces. But now we are going to deal with this question. This question is from Technical Sciences, November 2019, question 3. And it talks to Newton's third law of motion, and at the same time, it integrates Newton's second law of motion. So you must be able to deal with these particular types of objects. Now, let us go through this question. The question reads as follows. Crate A and crate B of different masses are placed next to each other on a horizontal rough surface. A hand pushing crate A causes both crates to accelerate at 2.3 meters per second squared to the right. Crate B experiences a frictional force of 25.3 newtons. Then they say to us, state Newton's third law of motion in weights. Now, my dear learners, this is what you need to understand, is you cannot just proceed to the question if you don't really study the physics behind what you have been given. So it is important that we actually look at the structure here and actually just try and understand what is happening before we go to the questions. Right. So here we have two crates, and one is called A, and the other one is called B. Now, they have different masses, we can see that, and A has a smaller mass, and B has a larger mass of 30 kilograms. And they are in contact with each other. Now, if they're in contact with each other, it means they are exerting a force on each other. So A exerts a force on B, and B exerts a force on A. Now, if they exert forces on each other, we definitely understand that that has to do with Newton's third law of motion, right? Now, if it has to do with Newton's third law of motion, it means we must think about the properties of these forces that A and B exert on each other according to Newton's third law of motion. Right. Now, if A exerts a force on B, B simultaneously exerts an oppositely directed force on A, and the forces are equal in magnitude. So that particular hand is pushing A, right? And that A pushes B, and hence we say A is exerting a force on B. And also, B will be exerting a force on A. So, the force that A exerts on B is our action force. And the force that B exerts on A is a reaction force. And the reason that A actually exerts a force on B is because they are in contact, and because there is a person that is applying a pushing force. There is a hand that is applying a pushing force on A, and A pushes B, and then B then reacts by pushing A in return. Now, that is a clear case of Newton's third law of motion, right? And we'll remember again, and I'm really emphasizing this, that this is an action force, the one that A exerts on B, and the force that B exerts on A will be your reaction force, because they come in pairs. They are action-reaction pair of forces. And again, they will be equal in magnitude. So the force that A exerts on B will be equal in magnitude to the force that B exerts on A. And they will act in opposite direction. So question 3.1.1, it says we must state Newton's third law of motion in weights. Now, from our understanding there, it should be easy for us to simply state Newton's third law of motion. Now, remember, when we state Newton's third law of motion in weights, right, we are going to take it from the examination guidelines. Are we together, my dear learners? We will take it from the examination guidelines so that we state it exactly as it is, and we are able to obtain all the marks. Now, simply stated, we know that when object A exerts a force on object B simultaneously exerts an oppositely directed force of equal magnitude on object A. So that is basically Newton's third law of motion. It tells us that A, if it exerts a force on B, then simultaneously, and I specifically took this answer from the marking guideline to show you that all the keywords there are important. Simultaneously, object B simultaneously exerts an oppositely directed force of equal magnitude on object A. Simultaneously, why? Because the two forces are exerted at the same time. They are exerted simultaneously. And it is oppositely directed because it acts in an opposite direction. And it will be equal in magnitude, right? Now, some of the mistakes that learners make, particularly in this question, learners would say, when force A exerts a force on object B. Now, that does not make sense. It is the object that is exerting a force on the other object. Hence, we say object A exerts a force on object B. So the object is the one that is exerting the force on the other. So we can say force A instead of object. We can say when force A exerts a force on object B, it must be a force that object A exerts on object B. And some of the learners, you omit critical words, those that we call keywords, like equal magnitude and opposite direction. Remember, the force that A and B are exerting on each other, they have the same size, they have a magnitude that is the same, but the direction will be opposite. So if the force that A exerts on B, like in this case, is to the right, the one that B exerts on A will definitely be to the left. As a result, be able to work with that, because those are actually the properties of action-reaction pair of forces. Again, we go to question 3.1.2, and there they ask us to calculate the force exerted by crate B on crate A. Now, if I want the force that B exerts on A, I can also remember that actually this force that crate B exerts on crate A is equal in magnitude to the force that crate A exerts on crate B. But the two forces will be opposite in direction. Now, how do we go and calculate that particular force? Remember now, there's not really an equation for Newton's third law of motion. And therefore, we are required to then go and use Newton's second law of motion equation. Right. Now, to be able to answer that, let us go here. The equation here, my dear learners, is F net is equal to MA. The equation is not F is equal to MA. Now, most of you, my dear learners, you actually don't go to your formula sheet and actually look at the formula. We give you the formula so that you can use it. We give you the formula sheet so that you can use it. Now, learn these formulas. Learn to refer to your formula sheet at all material times, because some of you will omit the subscript there, net. Or some of you will say FG is equal to MA. That is incorrect. You are changing the formula. And once the formula is incorrect, then we will not mark the rest of the substitution. So the formula must be correct at all material types. Now, we are dealing with forces here, right? And remember, I want to calculate the force exerted by crate B on crate A. Now, if I want the force that is exerted by crate B on crate A, it means I am interested in the forces that are acting on crate A. Are we together? I'm interested in the forces that are acting on crate A. But remember again, the forces that are acting on crate B and so on due to A, they will still give us the same answer. Are we clear, my dear learners? So let us start there. The net force is equal to the mass multiplied by the acceleration. Are we together? Now, if net force is equal to mass multiplied by acceleration, then I must actually go and calculate the net force. And to calculate the net force, it means I must do the vector sum of all the forces that are acting on the object. Now, we will remember the forces that are acting on any of these two objects. For us to actually know them, we must do a free body diagram. But we were not really asked to draw a free body diagram for this question. Now, let us just identify quickly all the forces that are acting on B so that I'm able to determine the net force on B, or all the forces that are acting on A so that I can determine the net force on A. Now, according to this, okay, let us just start there. The forces that are acting on B, number one, is the force of gravity that is going downwards. The second force is the normal force that is going upwards because this object is on a surface. The other force is the force that A exerts on B. Remember what we said, when someone pushes A pushes B. So there is a force that B is experiencing because of A, and A is pushing B to the right. So another force that is acting on B is the applied force. We call that force the force of A on B. Another force that is acting on B is the frictional force, because they told us crate B experiences a frictional force of 25.3 newtons. So I know the forces that are acting on B, right? Let us look at the forces that are acting on A. I have the force of gravity that is going downwards. I have the normal force going upwards because A is on a surface. Now remember, when A was exerting a force on B, then B exerted a force on A of equal magnitude but in the opposite direction. In other words, B was pushing A to the left. So A felt a force, and that force, we call it the force of B on A. And they told us these crates are placed next to each other on a horizontal rough surface. It means A is also experiencing a force of friction. Now, how can I get the force that B exerts on A? Now, you will agree with me that the force that B exerts on A is actually the same in magnitude as the force that A exerts on B. Now, if I look at B and I choose my direction to the right as positive, I can definitely see that the net force on B is given as the applied force plus the kinetic friction. Now, how do I know that it is the applied force plus the kinetic friction? Because the forces acting on B, the normal and the force of gravity, they are balanced. So only the forces that are that are horizontal on B are responsible for the acceleration of this object. And hence, for the net force, we include only the forces that are acting horizontally. Then we have that F net is equal to MA. So where I see F net, it will be the force of A on B plus that kinetic friction. These are the horizontal forces on B, and it's equal to MA. Then this is the force that I am looking for. The force of A on B is what I want to calculate, because the force that A exerts on B is actually the same as the force that B exerts on A. So now I'm actually calculating it as the force that crate A exerts on B. But then I will make a conclusion to say the force that crate A exerts on B is actually equal to the force that B exerts on A. So I am solving for this, my dear learners, the force of A on B. So this and this is the same thing. So we go, the force of A on B is what I'm looking for, minus, remember there, the reason you have a negative there is because the frictional force that is acting on B was acting to the left. Altogether, it was acting to the left. So if it acts to the left, it is going to be negative. Why is the left negative? Because we chose to the right as positive. So it is the force that A exerts on B minus the frictional force that was acting on B. They told us it's 25.3 newtons is equal to the mass of B is 30 multiplied by the acceleration. They told us the acceleration of B is 2.3 meters per second squared. And remember, acceleration is a vector. If it is a vector, we substitute it with direction. Now, because B was accelerating to the right, it means this acceleration is positive because we chose to the right as positive. Then we solve for the force of A on B. Now, to be left with force of A on B, it means I have to take this to the right-hand side of the equation, and it will become positive. That is why it is 30 times 2.3. Then I took this one to the right-hand side, so it will be plus 25.3. So the force of A on B, when we resolve it, it gives us 94.3 newtons. Now, my dear learners, this is the force that crate A exerts on crate B. But remember what the question was. The question actually wanted the force that crate B exerts on A. Now, I can make a conclusion that the force that B exerts on A is then 94.3 newtons, and it will definitely be to the left altogether. In other words, my dear learners, if I want to put this on an equation, remember, you have solved for the force that crate A exerts on B, but they actually asked for the force that crate B exerts on A. So you need to make a concluding statement to say, but the force that B exerts on A, which is what they're asking you for, is going to be equal to the force that A exerts on B, but obviously it will be in the opposite direction, which is the left, which is the negative direction. How do you know that? Because you have solved for the force that A exerts on B, which is positive, which is to the right. So the one that B exerts on A will be equal to the one that A exerts on B, which is this one, but in the opposite direction. Hence, when we resolve it further, it becomes the force that B exerts on A will be in that opposite direction, which is negative, but the magnitude will be equal. Then we know that we have to interpret that, and that will give us 94.3 newtons, and that will be to the left. And this is how 1, 2, 3, 4, 5, and 6 marks are allocated. I specifically took this as it is so that you can see it as it is from the examination guideline, that sometimes you have to be able to make conclusion statements to say that, oh, then the force that B exerts on A will be the same as the force that A exerts on B, but it will be in the opposite direction. And you can see a mark has been allocated there for any of these two. Right, and hence we have 94.3 newtons to the left. Now, what are some of the common mistakes that you make as learners? Now, in that question, some of the learners will be writing F is equal to mg instead of, rather there I wanted to say learners will be writing F is equal to mg or F is equal to ma. This is incorrect. This is not correct. This is not correct. Why is it not correct? Because this formula is a formula that we use to calculate the force of gravity, and even that one for the force of gravity, it will have the subscript g there. So Fg is equal to mg. This formula is not relevant and it's wrong in the first place, because it's the formula that we use to calculate the force of gravity. And even when we calculate the force of gravity, my dear learners, there we will put a G. So this is a completely wrong formula. Even this one, it looks correct, but it's not correct, because this one must say F net is equal to MA. In other words, learners omit the subscript net. So even there, the subscript net was omitted. And therefore, the correct formula must be F net is equal to MA. There, F net is equal to MA. And that is why you must use your formula sheet. Some of the learners will be substituting acceleration as 9.8 meters per second squared. In other words, there, the learners are substituting A as 9.8 meters per second squared. There, they substituted 9.8. That is wrong, because the object was not accelerating at 9.8 meters per second squared. They told us that B is accelerating at 2.3 meters per second squared. Remember, you were not calculating the force of gravity there, so you can't use 9.8. Are we together? And your object is actually not what we call a projectile, so it's not accelerating at 9.8 meters per second squared. Again, learners do not choose direction. I mean, you can come here and not choose direction. You are dealing with a vector. Net force is a vector, so you need to give us direction. So the forces that are acting to the right, if we choose as positive, then we will substitute those forces in a positive value. But if the force is acting perhaps to the left and you chose to the left as negative, then we put a negative. It doesn't mean the force is negative. It just tells us it is acting in that negative direction, and the negative direction in that case, or rather in this case, will mean to the left. Otherwise, if you just add them and this was positive, then you will get an incorrect answer because you did not do the vector sum of the forces acting on the object. You just did the sum. You must do the vector sum. And that part, vector sum, means direction must be taken into consideration. So, learners will then be calculating FB on A only. Now, what does that mean? It means the learner actually ends there, or the learner actually ends there by 94.3 newtons, and the learner does not give direction. That is a problem, my dear learners, because they said calculate the force. So the force is a vector. So you need to give us direction. So if they had said calculate the magnitude of the force, then it is fine if you don't give direction. But they didn't say the magnitude of the force. They said the force, and hence you need to give us your direction. So there we can see some of the learners will be giving us only the magnitude. And some of the learners do not realize that the force that B exerts on A is actually equal in magnitude to the force that B exerts on A, but in an opposite direction. In other words, they don't realize that if this one is positive, it's acting in the positive direction, which is to the right, then this one must be acting in the negative direction, which you have chosen as the left. Again, learners assume that the two crates had the same coefficient of kinetic friction while it was not stated. They also fail to recognize that F, the force of object A on object B, would be equal but opposite in direction to the force that object B exerts on A. We have already talked about that. In other words, they are telling me, or rather the explanation there is that learners actually assume that the frictional force that is acting on A is 25.3 newtons, and that is not correct. Why is it not correct? Because it was not given, it was not made obvious that the coefficient of kinetic friction acting on B between this crate and the surface is the same as the coefficient of kinetic friction acting on this object A and the surface. And hence some of the learners actually made those particular mistakes. So I am doing this, my dear learners, giving you a diagnostic report, showing you some of the common mistakes so that you are able to do better. Now, let us go to question 3.2.1. Right. It reads as follows. Two workers, Paul and Martha, are moving two trolleys, M and N, connected by a light inextensible string as shown in the diagram below. So it is light, the string is light, meaning you can actually neglect the mass, right? You just take that the mass is not affecting the system. Paul pulls trolley N with the force of 180 newtons to the east. Martha pushes trolley M with a force of 60 newtons at an angle of 28 degrees with the horizontal. Now, what I want my learners to know, there we have been shown that the force is 180 newtons, and they said is to the east. Now, you cannot say 180 newtons is to the right. So when you start to deal with direction here, you can either say let to the east be positive and to the west be negative. You cannot go and talk about right and left. And the other force there, it is acting at an angle of 28 degrees with the horizontal. So this is the same, a similar question to the one that we did yesterday on two body systems. But this one, it's the force is acting at an angle. So we are going to have to work with components and so on, right? So it's a two body system. Now the frictional force experienced by trolley M is 6.4 newtons. So the force experienced there, which is the frictional force, it's 6.4 newtons and it is kinetic friction. And then the one that is experienced by N is 8.58 newtons. So the frictional force experience is not the same. Then we are required to state Newton's second law of motion in weights. Now, I hope you remember that. Right, let us state it. It says, when a net force acts on an object of mass m, it accelerates the object in the direction of the net force. And then it says, this acceleration is directly proportional to the net force and inversely proportional to the mass of the object. And remember, I told you, you must state all of it from there and include there. Acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Now, what are some of the mistakes that the learners are making? Is that learners omit the phrase net force, right? So some of you don't necessarily omit the entire net force, but you omit the word net. So when you say, when a force acts on an object, then you are going to forfeit marks because it is the net force that acts on the object and it's causing it to accelerate in the direction of the net force. So make sure that there you include the word net. Right. Then question 3.2.2. They are saying to us, if the system accelerates at 1.09 meters per second squared, calculate the tension in the string. So I want you to take note of this. Please write this down. The acceleration of the system is 1.09 meters per second squared. And I want you to calculate the tension. So please take the question down. I'll give you a minute to do that. And then we'll go back to our question. And I want to give you 4 minutes because here we have 4 marks. I want to give you 4 minutes to answer this question. And then we are going to do it together. Are we clear, my learners? We are going to do it together because I've done these questions with you and I want to see what you can still remember. So on my side, I'm going to pause for 4 minutes while you are busy trying to determine this question. So the system is accelerating at 1.09 meters per second squared. Calculate the tension. Right. So there is your system. They are telling you the acceleration is 1.09 meters per second squared. Acceleration 1.09 meters per second squared. And you are required to calculate that, the tension. Your 4 minutes starts now. Right, my dear learners, your time has lapsed and we need to then deal with this question. So 3.2.2, a very simple one. We've been given acceleration. Now, if we've been given acceleration, all we have to do now is to just calculate the tension right away. It's not the same as what we've been doing where we actually needed two equations. When we need two equations and solve simultaneously, most of the time, that is when we don't have both the tension and the acceleration. Now, this easiest option was when you deal with trolley N, because now you don't have forces that are acting at an angle. So it becomes a little bit easier. Here you have horizontal forces. So here, my dear learners, again, remember, if we are, because we are going to use F net is equal to MA, we need to determine the net force. So there, the first force is the force of gravity going downwards. The second force is the normal force going upwards because the object is on a surface. One force again is the applied force. The other force is the tension force altogether. Right. The other last force as given here is that frictional force. So the normal force and the force of gravity, remember the net force vertically is 0. So the forces that are actually responsible for the acceleration of the object is this applied force that is going to the right. It is this tension force that is going to the left. We know how to do that by now. Again, it is this frictional force that is also going to the left. So three forces on the trolley N. So if we go here, F net is equal to MA. The net force is the force that is applied by Paul, and the tension as well as the kinetic friction because the object was accelerating, and that will be equal to MA. So these are all the forces that are making up the net force. Now, if we choose east as positive, remember this force was acting east, so we substitute it as positive 180. The tension is negative tension because it was acting to the left. The kinetic friction was acting to the left as well. It's negative 8,58. That's on N. And that will give you mass times acceleration. And the mass of N was 130. Right? It was 130 multiplied by the acceleration, which is 1,09. The acceleration is positive as well because it was east. Then you do your mathematics, you solve for tension, you find that tension is 29,72 newtons. So what actually happened for us to get there is that they took 180, subtract 8,58, we get 171,42 minus T. Then we take 130, we multiply by 1,09, we get 141,7. And then you take the 171.42, you take it that side. So you'll be left with negative tension is negative 29.72. In other words, T is also equal to 29,72. And we will deal with just this one because that is the easiest method that you could have applied to this particular question. So we didn't need simultaneous equation here because we knew the acceleration, but we didn't know the tension. So most of the learners here are actually going to try and use simultaneous equation, and yet it wasn't necessary. We just needed to get the tension because we knew the acceleration. So what were the mistakes here? Majority of the candidates, they still wrote this formula, F is equal to mg, so that is incorrect. Or they wrote F is equal to MA, so they omitted that subscript net. And also some of the candidates could not correctly identify all forces acting in each of the trolleys. And some of the reasons why learners didn't do that is because they don't draw free body diagrams because the question didn't ask them. So when you deal with forces all the time, my learners, you have to draw a free body diagram. Now they ask us, if Paul's pulling force is now applied at an angle of 60 degrees with the horizontal, what will happen to the frictional force experienced by N? Right only increases, decreases, or remains the same. Now, let's go back. If we apply this force at an angle, right? This 180 newtons, we apply it at an angle. This tells me that the normal force is going to decrease. Now, just know it like that, my dear learners. If you apply this force at an angle of 60 degrees upwards, then the normal force is going to decrease. Now, when the normal force decreases, the kinetic friction is also going to decrease. So you take this force that was applied by Paul, you apply it at an angle of 60 degrees to the horizontal. The normal force acting on this object will decrease. And therefore, if you go to the formula, kinetic friction is coefficient of kinetic friction times normal force. Because the normal force decreased, the kinetic friction is also going to decrease. So our answer there is decreases. Now, that is 3.2.3. Now, question 3.2.4, they want us to explain why we are saying the kinetic friction will decrease. Why we are saying this frictional force will decrease. And as explained, the normal force is going to decrease. And I told you, if the normal force decreases, the frictional force is also going to decrease altogether. Now, why is the normal force decreasing? So here, my dear learners, it means you also need to think about what is relevant to fully explain your answer. Because some of you would have just said the normal force will therefore decrease and thus the frictional force will decrease. Why is it decreasing? Because now there will be a vertical component of the applied force. What are we talking about? When you start to apply this force at an angle, there are two components now. The force applied at an angle can be resolved into a horizontal component as well as a vertical component. So now when there's a vertical component, the vertical component is actually trying to lift the trolley. So the normal force actually decreases. So that there are those forces, the vertical component of the force, as well as the normal, actually balance the force of gravity. So now the force of gravity is actually balanced. This downward force here is balanced by the vertical component of the applied force as well as the normal. And hence the normal is decreasing. Right, what are some of the common mistakes? In question 3.2.3 and 3.2.4, candidates really struggle to explain why the frictional force would decrease, right? when this force started to act at an angle, because they don't understand how the vertical component influences the normal force. So if that force is now applied at the angle of 60 degrees above the horizontal, then the normal force is going to decrease. And when the normal force decreases, then the frictional force will decrease. So that those were some of the challenges that some of you learners are experiencing. And just to conclude, to fix these errors, my dear learners, please use the examination guidelines to state your definitions and principles. Very important, because you will make mistakes. Use the formula sheet to copy down formulae as they are, so that you don't write things like F is equal to MA. Go to your formula sheet. And again, use your data sheet to correctly copy down the constant values like your G. Correctly copy it as 9.8 meters per second squared and use it where it is supposed to be used. Right, that marks the end of our lesson. I want to thank you very much. And I hope that you have seen some of the mistakes that we are not expecting you to make. And yeah, please take care of that, my dear learners. And I will see you tomorrow between 12:30 and 2:30 for our question and answer session. So feel free to send in your questions to this particular email. If you don't know it by now, I will just flag it for you quickly so that you can take it down. Right, to STEM Digital School at africateamgeeks.co.za. So you can take it down in the meantime, and that is essentially where you can send in your questions and I will be able to answer them. So the sooner you send them, the better. Thank you very much for watching and enjoy the rest of the evening.